In 1949, a scientist came up with what's called Bell's theorem, a personal favorite of mine. Bell's theorem was essentially this discovery. You can take a quark, an atom, and split it in half, and put one half in New York, and you can put the other half in San Francisco. If you take the quark in New York, and you reverse the spin of its electrons, at that exact moment, the half in San Francisco, its electrons will reverse their spin as well. If you've heard of the butterfly effect, that's essentially a popularizing of Bell's theorem. In New York State, in 1997, they discovered an exotic meson, and we all know how exotic mesons can be. This meson appeared for a trillionth of a second, and then it was gone. They don't really know where it came from, and they don't really know where it went. And so you have these unbelievably brilliant subatomic quantum particle physicists saying things like, I don't know. They have discovered a subatomic particle called a lepton. And the general consensus is that leptons do exist as individual subatomic particles. The only hitch is they've only been able to observe leptons in communities of 2 and 3. And so they say, yes, we understand that this is a single lepton. The problem is we only find them existing in groups of 2 and 3 oneness. And so the Newtonian understanding of cause and effect has simply taken a beating with quantum physics, because you take a picture of an atom, you take a picture of the same atom a second later, they don't know what it's going to do. Well, the assumption was always there's an element of predictability at the very bedrock, foundational part of the universe, but the problem is quantum physicists are just saying, well, when you get right down to the smallest thing that makes the thing that makes the thing that makes the thing, essentially the universe at its core is unpredictable. The best we can come up with is that the universe at its core is some sort of relationship of energy. So you have brilliant, studied, respected research scientists saying, all we can come up with as the universe at its core is made up of some sort of relational energy that we simply can't control. Some of them are even starting to use words like personality. And that this energy that holds everything together, that brought everything into existence and somehow sustains or holds everything in existence, gives life to everything, and simply has a mind of its own. We cannot conquer it or put it in a box. It is simply above and beyond what we can comprehend. High-end particle quantum subatomic physicists are starting to sound a lot like ancient Near Eastern Jewish poets. Now, for years there's been a disparity, because you have those trying to explain the weirdness of the bigness of the universe, my technical scientific language, the weirdness of the bigness, and then you have others at the quantum level talking about the weirdness of the smallness. But these two ways of explaining why things get so strange when they go big and why things are so inexplainable when they go small have essentially been two different ways. And so there's been a search for years for what's called a unified theory. Is there some way to explain why the universe, whether you go incredibly far out or incredibly far in, is just strange and unpredictable, and it bends, and light does all sorts of things? Is there some way to explain it all? And a group has come along who have said, well, the way to explain it is that the ultimate building block of reality is actually small strings. These are called string theorists, and they've presented to the world essentially what's called string theory. So you immediately say, well, wait, what do you mean by small? They're essentially saying the universe is to the earth as the earth is to an atom. The universe is bigger than the earth in the same way the earth is bigger than an atom, in the same way an atom is bigger than one of these strings. Yeah. And they're saying, well, the real issue isn't the bigness and the outness or the smallness and the inness. The real issue is multiple dimensions of reality. Now, to get our minds around dimensions, this is a rectangle and this is a circle. Now, this circle will never be a rectangle, and this rectangle will never be a circle. This board that I'm writing on is a two-dimensional surface. It has height and it has width. And so in 2 dimensions, this rectangle will never be a circle. This circle will never be a rectangle. If you ask me which is which, it's either or. It's either a circle or a rectangle. Now let's move from 2 dimensions to 3 dimensions. Let's add a dimension. This marker from the side is a rectangle. And yet, if you look at it from the end, it's a circle. So in 2 dimensions, it's either a rectangle or a circle. You add a dimension, and all of a sudden, what was either or mutually exclusive becomes both and. If the question was, well, is it a rectangle or a circle in 3 dimensions? Yep. How much blood has been spilled and oxygen wasted arguing over whether it's this or this, when maybe sometimes the answer is yep? Think about religion alone. Faith or science? Yep. Predestination or free will. And the one side has a list of Bible verses, kung fu, and the other side has their list of Bible verses, and maybe the good God who made everything is like, look, I gave you the marker trick. Yep. And you have the circle group, which is like, come on, man, join the circles. The universal loving embrace. Come on. And you have the rectangles. Wait, we have right angles. We are 4 times more right than you are. But you're dangerously close to becoming a square. Yes, what we need are more straight lines, not all this, what we need are straight lines. But dude, you can't smoke a rectangle. Maybe sometimes the good God who made everything just says, yep. Now, in the 1800s, a British headmaster named Edwin Abbott proposed a land of people who were trapped in 2 dimensions. What if there was a land of people who did not have 3 dimensions as you and I have, and they were trapped in 2 dimensions? He called this land Flatland. What could we learn as enlightened 3Ders if we were to spend time observing those trapped in 2 dimensions? How, if you lived in 2 dimensions, would you experience something that had 3 dimensions? What if you were trapped in Flatland and all you had was height and width? And what if you encountered a 3-dimensional object? What if my ring passed through your 2-dimensional world? What if a 3-dimensional ring passed through this flat 2-dimensional world? If this ring was able to pass through this marker board, how would they see it? Imagine when it first touched, it would be a point. Then as it continued to go through, the point would turn into a line, and then it would turn into 2 lines, and then when the ring was halfway through, it would appear as 2 different lines, and then if it kept going, the lines would come back together, point, and then it would be gone, correct? Because you talk about this all the time with your friends. You're out at a restaurant. I was thinking the other day, napkin, ring, I don't know. Now, how would these 2 process what they just experienced? How would the 2 of them, if that happened? Did you see that? A little weird, wasn't it? What was that? I don't know. Well, what did you see? Well, I saw a point, and it turned into a line, then it turned into 2 lines, and then the lines got farther and farther apart, then they came back together, 1 line, point, and then it was gone.